11 weeks of face-to-face, I mean physical lectures. So we're going to go with that. So the first 3 weeks of lectures, we're going to have online lectures. But I noticed that in the timetable, on the third week is Hari Raya. So during the third week, all right, the Hari Raya week, there will be no lectures lah. So we're only going to have online lectures this week and next week. All right. Because I think since this course is a calculation based course, so I think it's very important that to deliver the lectures through physical class lah. Right. So okay. So this week and next week sajalah yang kita ada lecture. Right, and then lepas tu third week tu consider as Hari Raya week lah, right? So today, this week, we're going to have what do you call it? mm, course synopsis and also lecture one lah on the introduction to the numerical analysis. All right, and then next week we will start with the chapter one. All right, so as you can see from, boleh tengok kah? Yang semua boleh nampak kan?
Boleh, Doktor.
Okay, so as you can see from this screen here, okay, so this screen shows the ITEL lah. So encourage everyone to join the, what do you call it, the ITEL for this course. All right, you just type in the course code, which is KA20602. All right, so I will start with the course synopsis of the course. So this course is a 2 credit hour, as you know. As you can see from the course code, the end digit is the 2. So if the end digit is 2, meaning that the course is a 2 credit hour lah. Kalau 3 at the end is a 3 credit hour. So this is 2 credit hours. And for the synopsis, the aim of the course is to develop the students' ability to solve complex engineering problems into more simpler and logical forms using numerical methods, right? And it is designed to narrow down the gap between the fields of engineering and mathematics, and mini project to be solved using the numerical analysis software will also be given to the students. So for the mini project, that one will be explained in detail in week 4 lah, when you come back for the physical lectures. And then the software is, again, we're going to employ Microsoft Excel. All right, but we're going to learn more functions lah in the Microsoft Excel. All right, so for the program outcomes, it's PO1, engineering knowledge, and also PO5, modern tool usage. And the course outcomes, there are 3 course outcomes. So the first one is to apply knowledge of numerical analysis in mathematical problems. So for C01, so you're going to learn different methods of numerical analysis, and then you're going to employ that method in a mathematical problem. So basically, it's just for C01, it's just a straightforward questions lah. All right, straightforward punya questions. And then for C02, again, you're going to apply the knowledge that you have learned in numerical analysis to solve civil engineering applications. All right, so this one will be a higher level problems, like where you're going to see what are the problems related to civil engineering that require you to solve by using numerical analysis. All right, and then for C03, to solve civil engineering problems, using a range of established numerical techniques and present the results informatively and effectively. So for CL03, this one is basically for the group project lah. All right, for the group project where you're going to be given a problems, and then you're going to solve as an individual, and then after that you're going to discuss as a group which solution is the most effective among the team members punya solution lah. But then you have to present your results in a report, and also you have to present in front of the class as well. All right. So the course outlines, there are 6 chapters. All right. For chapter 1 is the introduction to numerical analysis. All right. So this one will be covered this week. All right. And then for chapter 2, it is non-linear equations. So you're going to learn 2 methods to solve non-linear equations. All right. So this one, we're going to spend around 2 weeks. So 1 method per week. All right. And then for chapter 3, it is linear equations. All right, so there are 3 methods you're going to learn in this chapter. So elimination method, LU decomposition, and Gauss-Seidel iteration method. So this one we're going to spend around 3 weeks for this chapter. And then chapter number 4 is curve fitting. So there are 2 methods under curve fitting is Newton interpolation and Lagrange interpolation. And then chapter number 5 is the numerical differentiation. So for this, can someone please mute? All right. So chapter number 5 is the final difference of first derivative and final difference of second derivative. So this one actually can be finished in 1 week because it is a very straightforward punya method. So you can just we can learn it in 1 week lah, with examples as well. And then lastly is chapter number 6, numerical integration. And there will be 2 methods, trapezoidal and Simpson's rules, right? I think the heaviest chapters I think is chapter 2 and chapter 3 lah, because although it is although the problems is the same, but the method that you're going to learn is quite different lah. All right, so I think that's why I decided to spend 1 method per week for these 2 chapters. So for chapter 2 and chapter 3, we're going to spend around 5 weeks, right? And then for the course marks, you're going to have 4 assessments. The first one is the final exam. Final exam is 40%. And then we have one midterm test, so which accounts for 25%. And then we have a group project, which also accounts for 25%. But for the group project, there will be, I think, three, three, three assignment lah. I mean, I think it is the same. You're going to solve the same project, but what I mean by 3 assessment under the group project is the first one is basically you will be given the same problem, the same problem, but the first assignment is each student need to solve it individually first. All right, so each student need to have their own result lah. Okay, so that one will be evaluated is individual. And then the second part of the group project is group where you discuss as a group which is what is the solution is the best one among the group members. All right. And then the third assessment is the presentation. So basically, it's the same is the same project, but there are three evaluations lah. Basically, there are three evaluations: individual evaluation, group evaluation, which is under the group report, and then the last one is the presentation lah. Okay, so you will have to the submission is the group report and then also group presentation. But in the group report, there will be individual and also group punya marks lah. Okay, and then lastly we have one assignment. So that particular assignment is accounts for 10%, right? So all right. So for the group project, because I haven't decided your team members yet, so this time around, last semester, I selected the team members randomly. All right. Um, but for this semester, I would like to assign the team members based on your index of learning styles. How you, what type of learning styles you are. All right. So as you can see here, there are four types of index of learning styles. So I want to see the students punya learning styles lah. So as you can see, there are four what do you call it? Four types lah. Not four types. For how do you say this one? Yeah, four learning styles. So the first one is active and reflective. So you can see the definition. You can read the definitions here. So I want to see whether you are active or reflective learners. All right. And then the second one is I would like to know whether you are sensing learner or intuitive learners. All right. And then the third one is I want to see whether you are visual learners or verbal learners, meaning that whether you prefer to see, whether you prefer to learn by visual presentation or you prefer to learn through explanation by words lah. All right. And then the third one is the sequential learners or global learners lah. All right, so sequential learners prefer to organize information in a linear orderly fashion, and globally is learners prefer to organize information more holistically and random manner. So meaning that sequential is whether you prefer to sequential learners is where you prefer to learn step by step, or global learners is you prefer to learn from the top first, then you learn after you understand the big picture of the topic, then you learn the rest of the topic lah. All right. Okay, so I want you to take that quiz. So you just click this picture here, okay, and then you go to this website. I will share the website later lah in the WhatsApp group. So you go to this website, and then you fill up this section number 1, and then you click student here. All right, and then you please answer the section 2. Okay, there are 44 questions that you need to answer. So consider this is a activity lah for you this week. All right, so you need to fill up section 1 and section 2, and then you click submit. And then after you click submit, you will see your results. Okay, whether you are active or reflective, or whether you are sensing or intuitive, or whether you are visual or verbal, or and sequential or global. All right. So you need to take this survey or questionnaire and then submit your index of learning styles by 23rd March 2025. So you just click the questionnaire here. All right. And then you try to fill up the questions lah. So So I have also taken the questionnaire to see what type of learners I am. So for the active reflective, I discovered that I am more a reflective learner. All right, in which this it says that I prefer to think things through and understand things before acting. Okay, okay. So active is more like they prefer to doing something. Okay, and then act before they think lah, something like that. All right, and then for the second one is sensing and intuitive. So from my result, I'm more a sensing learner lah. Sensing learners prefer to take information that is concrete and factual. Right, so maybe the intuitive is the opposite of that. And then the third one is the visual learners lah. Visual learners. I'm my result is I'm more visual learners in which I prefer to learn through pictures, diagrams, and graphs, chart, films, and demonstration. Okay, and then the last one is sequential and more sequential rather than global learners. So sequential learners prefer to organize information in a linear orderly fashions. So I just want to see lah what type of learners you are, and then I want to match you up lah kalau yang tidak boleh lah semua active learners in one group, okay, and also like sequential learners because sequential learner ni dia kalau matematik dia that person is more sequential lah because they like to uh, uh, buat calculation step by step kan. So so when I apa tu make your groups, I'll try to match lah yang sequential and global in one group lah. Tidak boleh lah semua dalam satu, tidak boleh semua sequential tu dalam in one group. Okay, and also active and reflective. Active cannot be in one group lah, kena ada apa tu orang bilang kena ada um, um, diverse juga lah, diverse. But then I will look at more on the visual and sequential learners lah, dia punya differences because as engineers, uh, you as an engineer they prefer you to be a visual learners and also sequential learners. All right. So please try to answer this question and also apa ni submit your index of learning styles by 23rd of March 2025 so I can make your apa groups lah, alright, groups. Okay, so this one is the introduction. So any questions on the introduction for this course? So make sure you submit by 23rd, 23rd of March 2025. Right. Okay, so make sure you submit on time lah because that is one thing that I yang saya tidak berapa gemar lah, okay. Yang when I ask for when I give you the due date, you have to submit the date that I have given to you. All right, so it's just filling up the questionnaire and then submit to the questionnaire lah in this questionnaire section. All right. Okay, so moving on to the chapter 1. So I try to keep the lectures as short as possible because I think to me kalau online lectures ni tidak boleh panjang-panjang lah. Right, maybe paling panjang pun 1 jam. Okay, so for introduction, I'll try to keep the introduction as short as possible. It's just an introduction. But there are a couple of things that I would like to highlight in this chapter 1 because chapter 1 there are a couple of topics that often come out in your midterm test and also your either midterm test or final exam lah. All right. So this is an introduction. I have uploaded the slides in ITEL. So this is the subtopics of the chapter one. All right. So the introduction to numerical method, and then the significant figures, accuracy and precision, round-off error, transaction error, and error analysis. So what I would like to highlight here is the introduction to the numerical method, and also the accuracy and precision. All right. And then also the error analysis. So the others, you don't have to worry too much about it. It's just exposure to you. But when it comes to uh, the important part in this chapter is more to the introduction. I just want you to understand what are the differences between the numerical method and the exact method, and then also what is the differences between the accuracy and precision. The This one is more on the definition. And then lastly, which is the most important thing, is the error analysis, which is more on the calculation lah. Okay, so proceed to the introduction. Okay, so introduction. As a civil engineer, or as a engineer overall, one of the attribute that you need to have as an engineer is you are a problem solver. All right, a problem solver. So you are always come to the site, or maybe come to the lab to solve the problems. All right. So there are three methods that you can employ to solve the engineering problems. The first one is the experiment, by performing the experiment. All right. So that's why I think that's why this semester you started to have lab courses, because that is one part of the method to solve the engineering problems, is by conducting the experiments. So what is the, how do you say, benefits of experiment, advantages of the experiment? Is the experiment is the most reliable method, give you the most reliable results. However, the disadvantages of the experiment is they are very expensive, and then which require a lot of what do you call it, equipments, and then materials, and also consume a lot of energy and time, right? Although they are the most reliable, but they are also have disadvantages lah. And then the second one, that's why sometimes there are other engineers or researchers, they go for the simulation method. Okay, which is the second method that I have put it here, simulation. So the simulation is where you use software, graphic software like StatPro, I think BIM also. I believe you have already exposed to building information modeling, and I think there are also other like structural software like StatPro. Um, what else? Finite element math software like uh, StatPro. You have ETABS, Prota. Okay, so you solve the problem visually lah through software. Um, but the problem with the software method is, or the simulation method is, you require to have a high spec laptop lah. Okay, and then you also need to verify your results also with another method. Okay, that's why, which is mostly kalau yang lebih baik eksperimen lah. That's why experiment is number one. Then number two is simulation. Alright, but simulation ni, like I mentioned, require high spec laptop or computer lah. And then the third one is the mathematical model. Mathematical model is where you express the problems by converting the problems into mathematical terms or formula. All right. So that's why you learn the calculus one, calculus two, differential equations, engineering statistics, because when you have the engineering problems that you need to solve, you are to, if you cannot use experiment method or simulation to solve the problem, you can always use the solution, mathematical method to solve the problems. For instance, if for instance, let's say you want to solve the structural punya behavior under earthquake loading. Earthquake is a dynamic problem, or you want to solve it under fire punya loading. So, but you cannot, of course, if you want to solve it using experiment, it will be very expensive lah. Especially if you want to solve the full scale punya structural component like beam or column. And then so you go for mathematical modeling, but you need to find a way to express the problems, the what do you call it, the, let's say you want to solve the beam problem into the mathematical terms. So usually, like for instance, like earthquake problems or fire problems, you need to employ the differential equations that you learn in second semester. I think second order lah differential equations. First order or second? Oh, first order differential equations. Alright, first order or second? I'm not. I don't remember. It's first order lah. First. Oh no, second order. Second order differential equations. Alright. I remember the. I remember last time when I learned the structural dynamics, where you want to solve the structural behavior under wind or earthquake. You have these equations which involve the second order, first order, and also uh, the normal one lah. Okay, the y, d squared y over dx squared. You have to solve that one, dx dy over dx, and y. So if you cannot go for experiment and simulation, you are to solve it by using mathematical model. Okay. So this is the solution are derived analytically or numerically. This one will be explained later lah. Okay, about the what is the differences between analytical and numerical. But then we are learning the numerical analysis. Numerical analysis is the study of the algorithm that use numerical approximation for the problems of mathematical analysis. It attempts to find approximate solutions of problems rather than the exact ones. Right. So I think to understand better about the numerical analysis, just want to show you differences between the analytical models and numerical models. Also, if you go for mathematical models, you have to choose whether you want to solve the problem by using analytical or numerical models. All right. But it depends on the problems lah. So for instance, if your problems is very simple, like what do you call it? Like just only a beam, okay? A beam, and then your loading is not non-linear problems. It's only a loading yang biasa tu kan. So you go for analytical lah. In fact, the courses that you learn for the like applied mechanics, strength of materials. I think you learned that one last semester. Strength of materials, theory of structure one, and also theory of structure two. That one falls under analytical models, okay, mathematical lah. Actually, yang kamu belajar tu adalah mathematic punya models lah, the analytical, applied strength theory. That one all under mathematical models, right? And of course, ada juga yang this semester you also taking geotech 1, geotech 2. That one all under analytical models. And then this analytical models, they produce exact solutions. Exact solutions meaning that solution yang pasti lah. Okay. So the problems with the analytical models, they are limited to linear problems. Okay, limited to linear problems meaning that uh, you can only solve you can only employ analytical method if the loading is static loading. Okay, it cannot be solved if the loading is fire loading, wind loading, or earthquake loading. Okay, and then with simple geometry and low dimensionality. So simple geometry meaning that, let's say for instance, your beam is the cross section of your beam is I beam, rectangular, a circle. That one is still considered as simple geometry lah. And then kalau let's say for instance the geometry is complicated or complex, so that one you cannot solve by using analytical method. And then for the third disadvantages of analytical model is low dimensionality. So you can only employ analytical model if the problem has low dimensionality, meaning that it is not like multi-story building lah, meaning that you only solve like isolated ataupun isolated component lah, like you only focus on one structural component like beam, uh, column, frame. But when it comes to multi-story building, like 3-story, 5-story building, that one you cannot solve by using analytical model. So all of this if you cannot solve the problem by using analytical model, okay, sorry, ada masalah internet tadi. Eh, okay, alright, this one. Okay. Okay, so if the problems cannot be solved by using analytical method, then you can go for numerical method, which is the one that you're going to learn in this semester lah. Okay. So basically, it is the opposite to the analytical method. However, when you employ the numerical method, it requires a large number of tedious arithmetic calculations. All right, and then you can also to simplify the calculation, you can use software like MATLAB, Excel, SPSS, and etc. But for this course, we're going to employ Excel because I don't want to complicate kamu punya apalah assignment. Plus you plus I think the basic software that you need to have is Excel skills lah, and also Microsoft Word. I think that one is the basic skills that you need to have to before you go to the industry. All right. All right. So and then if we go to the other slides, I think this one is just want to explain to you the different types of numerical methods, which I will explain later every week lah. So these are the types of numerical method, the the numerical problems. So the first one is the nonlinear equations. Okay, I just mentioned the method lah, but the details about this problem will be explained in the lectures after next week. So we have the nonlinear equations, and then we have the linear algebraic equations in which you have to solve the two or more than three equations. And then you have the optimizations. You want to find the maximum and the minimum values of a data. And then you have the curve fitting, so meaning that you want to find out the best lines among the data that you have collected. And then the interpolation is to find out the intermediate values between the relatively error-free data points. And then you have numerical differentiation and then the integration. So the concept is the same as you have learned in calculus 1 and also in the DE, differential equations, but you're going to employ numeric but then it is transformed into the numerical differential equations lah, and then numerical integrations. To me, it is a lot simpler than the normal differential equations and integration method. However, dia ada banyak equations lah. Oh, sorry, banyak formula lah that you need to learn. Alright, but it is straightforward. Okay. One more thing I forgot to explain to you about the disadvantages of the numerical solutions. Numerical method, although it can solve what the analytical method cannot solve, but the result that they produce is approximate solutions. So approximate meaning that it is not the true solution lah. So there will be errors in the solutions that you produce using numerical method. So the more reliable method is actually analytical method, but it has its own disadvantages. That's why you go for numerical. But numerical punya disadvantages is it cannot give you the exact solution. So when you are employing this method, you need to allow some errors lah in your calculation. All right. So we have this one, interpolation, numerical differential equation, differentiation, and then you have the ordinary differential equation. So this one will not be covered because we only have it is a 2 hour credit 2 hours 2 hours punya course. So I'm not able to cover this one due to the time constraint. We only have one lecture per week. And then we have the partial differential equations also will not be covered in this course lah, right? So I think the next one is about the significant figure. So but then I know that you already are familiar about the significant figure because numerical analysis ni you need to allow some errors. So you need to allow when you give your answers, you need to present in the significant figures lah. Kalau dia bilang give your answers in 4 significant figures, so you need to provide lah your answers in 4 significant figures. Alright, so you need to understand that when it comes to significant figures, you count the numbers starting from the numbers that is more than zero lah. Jadi kalau for instance, if you look at question 1.1, if you have 0.01688, the significant figure starts with number 1 and then 6 and 8. So in this, okay. So this one I'll just just skip lah. Just skip because I know that you already familiar about the significant figures. But I would like to cover this one, significant figure, the accuracy and precision. So the differences between these two lah. So what is the definition of the accuracy? Accuracy refers to how close a particular measurement to the exact value. Okay, how close the measurement to the exact value, while precision refers to consistency of repeated measurement. Right. Um, so the best measurement is accurate and precise. Okay. So you want your in the numerical method, you want your result or your solution to be as close as possible to the exact value. All right. But then you won't be able to get your answers as the exact value, but you want your result to be close to exact value. And because numerical analysis ni ada uh, any is subjected to error, you want to repeat your calculation lah, more than one, or you want to repeat your work more than one. So when you perform your numerical calculation, the consistency in your result also reflect how accurate your how uh, how accurate your result is. So let's say you repeat your calculation more than one, and then if the let's say three times. So if the three times of your calculation, the result is consistently close to each other. So meaning that your solution is precise lah. Okay, so you can see the differences between the accuracy and precision in this picture here, um, by using this arrow lah. Okay, so you can see that from the first figure here, okay, there are about six measurements, and then all of the measurements are far with uh, far with each other. They are not close. And then if they are not close, that one we can call it as imprecise because they are not consistent. But and then as you can see also the all of the points, they are not in the middle punya answer. So you can say that it is inaccurate because it is not in the middle. All right. So from this picture, you can say that the measurements are inaccurate and imprecise. And then if you go to the right, all of the measurements they are uh, close to the middle one, which shows that it is accurate. However, there are still gaps between the measurements. So that's why we can call it as accurate and imprecise. And then if you go to the bottom left, all of the measurements, they are far from uh, the, the midpoint. However, they are close with each other. So that's why we can say that these measurements are inaccurate because they are far from the midpoint. But since they are close with each other, they are precise. And then the last one, all the measurements are in the midpoint, but and also they are close with each other. So you can say that they are accurate and precise. So take note on this slide because I often ask these questions, the differences between accuracy and precision to the students lah in the kalau bukan di midterm di final exam, right? So for the run of errors ni, I don't want to touch on this one too much, but just want to take note on the run of error lah. chopping off error and round off error. Okay, if you look at the differences between chopping off, okay, let's say you are considering the pi, the if you translate that into numbers, you have 3.1415926. All right, but if you want to employ the chopping off error, let's say you want to present your answer in four significant figures. All right, if you chopping off, you just totally cut it off up to the four significant figures. So that's why you can see you get 3.1415, which is you just take it out from the numbers of pi lah. But then if you're rounding off, meaning that at the end of the numbers, in this case is 5, so you want to change the number, the last number, into the nearest number. Let's say this 5 is near to 6 because the next number to 5 is 9. So when you round it off, you present your answer as 3.1416, not 3.1415. Okay, so just take note on this one lah. Okay, chopping off and rounding off. So because there will be questions where I will ask you to present your answer in four significant figures by using chopping off and rounding off lah. So as long as you understand the what do you call it, the concept, what is chopping off and rounding off, you should be okay lah. Okay, so just this one is just an example lah of the potential questions. Like let's say this one in question 1.1, perform the calculation below and then present your answer in exactly and then present your answer in exactly punya presentation, where you have to present in the fraction punya presentation lah. And also the second one, you need to translate that into significant figures, but by using chopping arithmetic, chopping off lah. And then the third one is 4-digit rounding arithmetic, where you just rounding up according after four significant figures lah. Okay, so these are the solutions, so you can look at it in your own time. Okay, so also this one 1.3, so be aware of this one lah, because in your midterm test pun akan ada these questions lah. Alright, so please ignore the transaction error. Okay, so this one is not exactly significant lah, significant in civil engineering. Okay, so just ignore the transaction error. But the last one that I want to touch on is the error analysis. So this is very important. Why? Because as you know, numerical analysis produce approximate solution. So it is subjected to errors. Okay, so there will be cases where you have to compare. You have to compare your numerical result with the exact result lah, exact result, to see what are the errors between the approximation values with the true values. All right. So there are in practice, it is important to note that computed solutions are not exact solutions. All right. So you need to be aware of that. Although it can solve nonlinear problems, high dimensions problems, but they are not accurate lah. They are not exact solutions. Perfect accuracy in most computational process is impossible. Right? It is impossible to get exact solutions for the numerical problem, but you need to allow for errors lah. So it is imperative to make certain approximations. You need to allow some errors in your calculation lah, basically. All right. So whether it is 2%, 3%, so it depends on uh, uh, how much accuracy that you want lah. Okay, so the error in a computed quantity is defined by the relationship between exact solution or the true value and the approximate value or estimated value. Okay, so there are different terms lah, different terms that you need to know juga. So usually it's either exact or true. So basically they are the same meaning. And then when we're talking about numerical solution or numerical value, the other term that I can use is approximate value or estimated value. All right, so they are the same meaning lah. Okay, so what is the formula to the error? Is to find error, you just subtract the true value with the approximate value. All right, so xt meaning true value, and then xa is the approximate value. So approximate value you obtain from the numerical analysis, okay, and then true value you obtain from the exact analysis, okay. So for instance, kalau you are given this problem to differentiate these equations, and then this equation is very complicated, but it can be solved by using true and also by using numerical. So first thing first, you need to solve the problem by using differential equation that you learned in calculus 1. Okay, it's a very straightforward, right? You just differentiate the equations, but then after that you need to solve the same equations by using the numerical differentiation method, which you will learn in chapter 5 lah. Okay, and then after that you want to find out what are the errors between the two. All right, so basically that is macam itulah basically. And then absolute error is you just put the bracket inside the error punya formula, meaning that everything, all the values will become positive lah. So you don't care about the, what do you call it, the signs of the errors, because it's the same thing. It's minus plus error is still an error lah. Okay, and then when we are to find out the percentage error, okay, relative error is error divided by true value lah. Okay, relative error is once you obtain the error, you divide the error with the true value. Okay, that is relative error. Okay, and then for the true percent relative error, okay, after you get the relative error, you just multiply it with the 100 to get the percentage error lah. And then the approximate percent relative error, okay, this one is when your calculation is there is a sequence in your calculation, so you want to compare your calculation from the previous one with the present one. So this one is, we call it as approximate error lah. So it's error within the calculation that you employ. So usually it is in the non-linear equations lah. You want to, sorry, in the linear equations. So in the linear equations, there is a multiple calculations that you need to perform, and in every calculations, you need to compare the present calculations with the previous calculations. And then after that, you multiply with the 100 lah. Okay. Because as you know, numerical analysis is a tedious calculation. So you want to see where you want to stop, where you need to stop. So sometimes there is a question where they will ask you to calculate this problem up until the relative errors is 5%. So if you cannot get up to 5% relative error, so you cannot stop the calculations. So you need to perform the calculation sampai you dapat relative error equals to 5%. Okay, so usually you start with 90% and then 80%, 60, then up to 5%, then the solution will be considered as acceptable lah. Okay, so these are the examples. So usually what I do is we will do it together lah in the class, but um, I think do it because I don't have my equipments, so I can just read it out here for the question 1.5. So, but these errors will be employed in every chapter that we're going to learn lah. Okay, so I think you will learn through the examples that we're going to cover for the next weeks lah. Okay, so this one is for maybe this one a very straightforward one. Question 1.5. Find the absolute error and relative error for values given below. Okay, so you have the let xt. So xt is the true value. Okay, and then you have the xa, which is the approximate value. All right. So you want to find the absolute error and relative error. So you just go to the formula here. Okay, you have to absolute and relative. So you have absolute and relative. So basically, you just um, employ the numbers into the formula, and then you will get the absolute error and the relative error. All right. So absolute error, again, I explained, absolute error is the difference between the true value and approximate value. And relative error is where you divide the error with the true value lah. Okay. So for part B and part C is also the same. It's different numbers saja. But basically, you just need to employ the numbers into the errors formula. Okay. So just remember the concept lah. The concept of the error is to find out the differences between true value and approximate value. Okay, or exact value with the approximate value lah. Okay. So take note on question 1.6. Okay, so you need to look at this one as well. Okay. Later on, I will provide you the past paper lah, so you can have a feel of what type of questions in chapter one that you can expect lah. So mostly in chapter one is more on the calculations of the numerical error analysis and how to present your answer in the significant figures that are required uh, from you. Okay, so this one, question 1.8. Oh, this one, 1.10 ni kamu, I think this one can be ignored lah because this one is Taylor. Yeah. Okay, so I think, yeah, I think this one also important. Now 1.14, this one is apa orang bilang? This one is engineering problems, okay, where you need to measure the height of the building and then you need to find out, or you want to compare between the error and true percent relative error. So I have provided the solutions here lah. So this one I have released this one before, and then I discovered that the students not able to answer lah. Oh, soalan sama, tapi saya pusing ayat dia saja. Tapi the student not able to answer. So yeah, take note on these questions. Okay. So I think that's all for chapter one. So I don't want to keep you too long lah because my plan is only 1 hour lah for online lecture. So I think next week we will proceed with the chapter one, which is what do you say? Bisection method. All right, and in the equations, bisection method. Okay, so for your attendance, so okay, so you can scan. Just 1 second. Okay. You can try scan your ini, scan your attendance. Okay, tak dapat tak? Okay. All right, so before we end our lecture, please don't forget to take the index of learning styles punya questionnaire lah, and then submit your ILS score in ITEL by 23rd of March 2025, which is this Sunday lah. Okay, right. So I think that's all, and I'll see you next week on Tuesday. Right. Thank you, everyone.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
Ya,
Thank you, Doctor.
patangan pa
Thank you,
itu.
Dokter.